Hello everyone, welcome to session 9 on isometric projection. Here we are doing the main problems, what you are likely to get in the video examinations or any university examinations in that way. Okay, here there are two solids. A sphere of diameter 45 mm rests centrally on a frustum of a cone of top diameter 25 and bottom diameter 50 and height 60. Okay, draw the isometric projection of the combination of solids. Now you see here, this is the sphere of diameter 45 and this is the frustum of cone. How will you know is a frustum of cone? Because there are two circles here. One circle 50, another circle 25 will represent the, and with height 60, okay, will represent the frustum of cone. See here, and 45 diameter, no, what I have given here, this is the top, front view is also a circle, top view is also a circle, means it's a sphere, okay. And for frustum of cone, 25 and 52 circles and height 60, since the top view is circles, two circles, it is clearly the frustum of cone of height 60. Okay, in that way you are able to identify the top surface, top solid is a sphere of diameter 45 because circle in the front view, circle in the top view, 45 mm circle, and bottom solid is frustum of cone because its height is anyway 60 given in the front view. Okay, I have written in the front view, and in the top view it is two circles, one 25, another 50. And as you know here, this 25, when you are looking from the top, this 25 mm circle cannot be seen because it is obstructed by the solid itself. That is why 25 mm diameter, I have made it as dotted. Okay, invisible. Now you see, as usual you start, you see here C to C1, C1 to C2, this is a common axis. Okay, C to C1 anyway is isometric. C1 to C2 is also isometric because this edge is parallel to the principal edges or vertical edges of a standard principal solid, that is square prism. In that way, C1, C2 will be isometric. C to C1 will also be isometric. Okay, now what you do is, first you do the bottom solid. 50, 50 ISO, 60 ISO 25, in that way, this, and draw this tangent to this tangent to this, and the back portion you make it light, top surface, tangent, and this portion make it light. In that way, this frustum of cone has been done already in sessions 1 to 5. You just look to that, how it has been done. Now I have done this. Now you have over this solid a sphere of diameter 45. As I said, spheres don't reduce in the diameter. If whatever the inclination, the sphere will always look like the same sphere of same diameter. In that way, since spheres do not reduce in diameter, you have to take care of one step here. Now you see here, C1 to C, this is 45, no? This axis, this distance is, as you see here, it is 20 to 45, the thing. You take 22.5. It is, you don't take 22.5 actual. 22.5 ISO you take. 22.5 into 0.816. That is, get the center C, this center C2. Okay. Now once you get this also let us say it is C2. Okay. Now you move this. That is, move, don't copy, move this sphere with respect to C2 and coincide with this C2. Okay. And you know very well, this radius is actual 22.5, but this is ISO 22.5 because axis is isometric, which will reduce in 0.8, which will reduce in length, that is 0.816 times the original length. That is why this C1 to C2 you take 22.5 ISO, get C2, then this is actual diameter 45, that is 22.5 actual. Now you move it. Now once you move it, you have got the problem right. That is, top solid is, anyway, this is 22.5, in that way draw. This is ISO 22.5. Now the top solid anyway should be seen. This is a sphere, and once the top solid sphere is darkened, you come to the bottom solid, top surface. This portion of it will be invisible. You make this portion of the top surface or the bottom solid invisible, and since the left surface, right surface are not seen, this generators you draw, they are anyway non-isometric edges, and then this portion and all that is invisible. I have shown already. In that way, you have completed isometric projection of this two solids. The top solid is a sphere of diameter 45 and bottom solid is a frustum of cone with bottom circle 50, top circle 50 and height 60. Now you see here, this is the isometric projection. Okay, and I have told you just to actually you can stop at this stage only. Okay, you can stop at this stage only for the examination and all that. And just to help you in the next chapter, I am introducing with you like other problems how to draw the orthographic projection of this. Now you see here, if you take the front view like this, front view can be taken either this way, right, or left also, here also. Okay, if I take the front view here, first concentrate on the front solid. If you see the front solid, this front solid, it will look like this. You draw this. This will be 25, as you see here. This is 25. You see here, this diameter is 25. This is 25. And this is 50, you see. Okay. In that way, you draw this base solid. Okay. Bottom solid 25. This is 50. Height is 60. You draw. Okay. In that way, you draw. Then after that, you concentrate on the top solid. When you draw the top solid, it is 45 in the front view. This top solid in the front view, it is 45. Draw the 45 and draw 45 mm diameter here also. 45 mm diameter circle and draw diameter here also. Once you draw this, when you are looking from the top, this cannot be seen. Hence, this portion you make it invisible. That is dotted. In that way, you are getting not only isometric projection but also orthographic projection in a perfect way. Okay, this will anyway help you in the next chapter. Please concentrate. Next, you see here, there is a problem here. A square prism of sides 40 and height 50 rests centrally on a cylinder of diameter 100 and thickness 20. Okay, now you see here, this also we are done. We will not take too much time. It is 100 mm, thickness 20. You draw cylinder. This iso cylinder you draw. Okay, iso cylinder. This is not 100, and this is iso 100. 100 into 0.816. That is, you first do it to the actual thing and select the entire thing and scale it by 0.816, as I told you earlier. This has been done in the earlier sessions. You please take care of that. First, you do this. On the top of it, you have a square prism of sides 40 and height 50. This also you do. Now, as you know here, once you draw square prism of sides 40 and height 50, okay, and this 30 and all that you do. And finally, top surface, left surface, right surface to be darkened. You darken that also, make it ready. Okay, all other things should be light. Even here also, the top surface is darkened, and this back portion and all that, the back portion of the elliptical curve, this will be made light and all that by splitting here. And this is tangent to this. Okay, tangent to these two ellipses, this thing. In that way, the cylinder is completed. Okay, now what you do? This has to be placed centrally over this. What do you do? Get the center here. Okay, center here also, and move this with respect to C. Move this square prism with respect to C. You do this way. Once you get this, you know very well, this is isometric projection more or less completed, but you have to take care of the visibility, which is most important here. The visibility is always top surface, top solid. Now, top surface, top solid means the square prism, top surface, anyway it has to be done. Darken the top surface, darken the left surface, darken the right surface. Then when you come to the bottom solid, first top surface, left surface, right surface. Okay, top surface, this portion of the thing cannot be seen, hence make it light. Okay, hence make it light. And since the left surface, right surface are not there because it's a curved surface, you just leave it as it is. Okay, now this is the isometric projection. As I said, you can actually end at this stage only. Okay, when isometric projection is asked. Now, I'm introducing you with the orthographic projection also here. Let us say the front view is this. When front view is this, concentrate on the bottom solid. Okay, it is, you see here, it is front view, it is 100 diameter. This is 100 by 20. Okay, is the bottom solid. And looking at the circle here, you will know that it is a cylinder of diameter 100 and thickness 20. Okay, then in the same way, you see the second solid which is above this. This is, the height is 50 for the second solid, the top solid. Height is 50. When you come to the top, it is square 40. That means it is a square prism of sides 40, base sides 40 and height 50. In that way, looking at the front view, top view itself, you will know what are the solids placed, and this is the orthographic projection, what I've mentioned here. Okay, this is. Next, we'll go for the next problem, main problem 24. Now, it is a frustum of cone of top diameter 25 and bottom diameter 50 and height 60, resting centrally on a cylinder of diameter 100 and thickness 20. When it, okay, draw the isometric projection of the combined solid. This, you know, again, it's a repetition more or less. Okay, first you draw a cylinder of ISO 100 like the previous problem. Same way, it is already done in the sessions 1 to 5. Then you complete the frustum of cone also. ISO 50, ISO 50, ISO 25 and height is 60 and all that. Then once you do this, okay, this has to come and sit on the top of the cylinder centrally. Okay, get center C here also. Okay, move with respect to C now. Move with respect to C. Now you see here the visibility for isometric projection is always top surface, top solid. Darken the top surface. Okay, then draw the tangents to this bottom ellipse and back portion you have made it already light. Okay, that is doing this. Top surface, top solid is already completed. Once you place the top solid, now you go to the bottom solid, top surface. This is top surface. This portion is invisible. You make that invisible. Okay, then draw tangent here for the bottom ellipse, and this portion is light and all that. You would have already made it light. Okay, now once you do this, this is isometric projection is already over. Okay, now you can actually stop at that. I have told you, in case if they give the front view as this direction in the next chapter, okay, if this is the direction of front view, this take the bottom solid. Bottom solid is 100, that is, this is 100 by 20, height thickness 20, and tops are the diameter is 100 here, and this is 20. As a result, the bottom solid is looking at diameter 100 and thickness 20. Thickness 20. It clearly says it is a cylinder of diameter 100 and thickness 20. Okay, and looking at the next solid, that is this top solid, looking at 50 diameter and 25 diameter here and height 60, it clearly says it's a frustum of cone of height 60. Okay, and if you look at the top, it is a two circles are there. It clearly says a frustum of cone. Okay, with the bottom diameter 50 and top diameter 25, and bottom solid, it clearly says it is 100 mm diameter and this is 20. In that way, it is a cylinder of diameter 100, thickness 20. In that way, orthographic projection is also completed and this isometric projection is also completed. This completes the next session. Okay, thank you for watching.